So 4 miles of acceleration. And so you'll note there were 5 labs you did. The first 4 are different miles of acceleration. I'm going to try and the 5th one's a special case of one of those. So we're going to try and give this a go. So look at the first experiment. We had the cart, we were rolling it down the track, right, away from the sensor. Is that correct?
Yes.
So who can describe to me what their graph or position looked like? Brian.
It was kind of like an exponential.
Okay, now they're all, I think they're all exponential graphs, I think.
Okay. So
all 4 labs have the exponential graph.
So it started off with a relatively small slope, and then the slope got steeper.
You would call it an upward opening parabola.
Okay.
Agreed?
Sure.
That correct?
Yeah.
Right there.
That is correct.
Okay, thank you. Very good. So, who can describe? So this was the motion, the position graph of the first part. Can someone describe for me in layman's terms what that motion was? Kind of like, I guess, we start answering question G for this first graph. What can you tell me? So what is increasingly positive?
Slope.
Okay, so the slope is increasing and positive, and what does the slope of the position graph tell me? In general, what is the slope of the position graph? Don't worry about this graph per se, but in general, if I have a position graph, what does the slope tell me?
Velocity.
Velocity, good. So this graph showed me an increasing positive velocity. Okay, we know this because if we were to draw tangent lines sort of on this graph, we draw one like there, draw another one up here. Those 2 lines, if you go from one to the other, the slope gets steeper and the slope is positive in both those cases, right? So that's when Claire said increasing positive slope, that's what she means, that the slope of that first line, second line gets steeper. And they're both positive slopes to go along. So this graph showed me increasing positive velocity. Questions about that? Their velocity graph
is increasing in the positive direction.
What's increasing?
The velocity.
Constant slope?
Yes.
Like that?
Yep.
Nice. Good. So here is our velocity graph. We should have seen a constant slope, should be a positive slope like that. Now some of you may have drawn too much on your papers, so maybe why you're confused if you drew the extra stuff all around it. But the bulk of it, if you lined up with the position graph, should have looked like that. So do you think, someone can answer this, does that red velocity graph match up with the word description we used for the position graph? Do those 2 things match up?
You said it was increasing positive velocity, and as you go up the y-axis of where velocity is shown, you keep going up, so your velocity increases over time, so you're increasing positive velocity.
Okay, let me ask you this then. Is this also an increasing velocity?
Yes.
Why?
No.
No. Okay, so why is that upper velocity increasing?
Because it's going away from the origin.
Good. So in the velocity graph, increasing or decreasing has to do with your relationship to the x-axis. So in this graph here, my velocity is moving away from 0. It's getting bigger in value. Think about it as going like 2, 3, 4, 5 as you go up this axis here. So it's not just that you're moving up the axis, because of what we just showed the example. It's moving away from 0. So this has an increasing velocity. And how do I know this velocity is positive? Do I know it's positive? Can I tell this velocity is positive? Or is that also a positive velocity?
No, it's going up and away from the
Up and away. That's not y. Yes? Is y?
A positive slope.
So is that a positive velocity? Okay. So it's not just a positive slope. It's not just up, Sean.
Is the value of the function positive?
You mean because it's in the first quadrant?
Yeah.
Good. Because this line exists entirely in a range where we're in the positive y-axis, it's a positive velocity. It has nothing to do with the slope or anything else. It has to do now with the value is always where the line is. So because this line is in the positive, is a positive value, we know that it's going to have a positive velocity. So any velocity in the first quadrant, right, the value of something, the slope doesn't matter. Like for the position graph, it didn't matter what the slope was. No, I have a positive position. I can be moving to the left, have a positive position. To find the value of something, you look at where it is. To find how it's changing, you look at the slope. Okay, so this one's getting faster because the slope is taking it away from the line, the x-axis. Positive is in the positive region. Acceleration, how'd this graph look? Or how should it have looked? And positive value, good. Just should have been a horizontal positive line. This tells me that I have a positive acceleration and that it's constant. Why is it constant? What was causing the acceleration? Good, but it's gravity. That's why, in general, in a more broad sense, acceleration in this lab is positive because gravity was causing it. Gravity is a positive or constant acceleration. And mathematically speaking, we would know the acceleration is positive because our slope of our velocity graph was positive. So as we go down these graphs, x, v, then a, it's all about the slope. The slope of this one gives us the value of the velocities. The slope of this line gives us the value of the acceleration at any given point. Okay? Questions about our first model? Okay, so we have a positive motion, increasing velocity. That's acceleration number 1. Woo! That's the easy one. I know, Mr. Comfort. Killing me. Blah, blah, blah. Okay. Next one. What we're doing, we push the cart up the ramp away from the sensor. How did this first graph look? Anybody got anything good here? Oh, clear.
Like this.
Like a square root graph?
Like a yeah, kinda. You're
Should've
a
looked-
sloppy one, yeah.
Thanks. So if you were to graph y equals square root of x, you should get this graph, roughly. So it should start off with a positive slope and then start to flatten out towards the end. Okay? So who can, in words, describe this one to me? Explain to me what's happening here. Joe.
It's got a decreasing slope,
Which means that it's decreasing what?
velocity.
Okay.
It's positive, and
What's positive?
the slope
Which means that what is positive?
velocity.
So you're claiming it's a decreasing positive velocity.
Yeah.
Because again, we see the slopes. If we draw tangent lines here, the slope of this tangent line is steeper than the slope of that tangent line there. And so it's still positively sloped. Okay? Eventually that would flatten out. So that means it's slowing down. Woo. Velocity graph, what do we have for that? Thoughts? Anybody want to describe theirs? Yeah. Beautiful. Does that, Sarah, does that agree with our first graph?
Yeah.
Why?
Because it's traveling towards the origin.
Which means what?
It's decreased.
So slowing down.
Yeah.
And then is it moving forward?
It's still positive.
Good. So it's positive value, or we think about it's above the x-axis. So whenever we're above the x-axis, we have a positive velocity. Because if we were to pick one of those points, it'd be +5 or +4 or +3 for the velocity. So any one of those points is still a positive velocity. This is one of the ones that's going to start messing you guys up now because you have a negative slope. So a lot of you are going to want to think it has a negative velocity. Differentiate slope and value. So.
I just have a question about what you were saying earlier. If the,
What did I say
value
earlier?
of the velocity is like getting more negative,
Yeah.
are you still, you were saying that you'd say it's increasing now? Is that right?
Well, it depends. It depends where I
It's
am.
going away from the x-axis.
If I was down here, I would say it's increasing.
Okay.
If I was in the bottom of the graph, but on top, I would say it's decreasing until you get to 0.
Yeah, no, I'm talking about in the fourth quadrant.
Yeah.
Even though it's getting more negative, you're still saying it's increasing.
Okay, let me ask you: if a car's going to hit you, would you rather it's go? Would you rather it's going -5 or -20?
Negative 5.
Yeah. So -20 is a bigger value, right?
Well, the speed is.
And because All you gotta do for the acceleration graph is look at the slope of the velocity graph. Slope of the velocity graph is negative, acceleration is negative. Don't even gotta think. Okay? And that means we have a constant negative acceleration. Questions so far? So that's model number 2. They keep getting harder. What do we have for that graph? Anyone want to try to describe it? Just start off roughly horizontal or positive, slight negative velocity. Something like that. So who can explain this to me? How about Jared in normal terms, in layman's terms? I get talking to a freshman. How would you explain this?
It's getting faster in a negative direction.
So I'm going to say increasing velocity, correct?
Yeah.
Negative direction. Mike, do you agree?
Yes.
Good. Somebody have another paper? Yeah.
It's a line moving away from the origin of the negative slope.
Is that what you meant? Do we think that those two graphs agree? Christina, what do you think?
Yes.
Can you elaborate? Why do you think that?
It still has the increase in velocity, even if because velocity doesn't have doesn't matter if it's negative or positive.
What makes it increasing?
The fact that it's moving away from the origin,
Good, so we're away from the origin, so it's still increasing velocity, good.
and then it has a negative direction because it's below the x-axis.
Beautiful. So I have a negative value, so I'm down there. I have it all negative, negative 2, negative 3, negative 4, negative 5, negative value, and then I'm going away from the x-axis, so I know it has an increasing velocity. I want to draw a down arrow there, but it's going to mess people up. So increasing velocity. Okay, those two agree. And then acceleration graph, how'd that look? Like that, negative constant acceleration. Yes, Brian?
I noticed that for the velocity graphs, you're not putting it at the 0, 0. Is there any reason for that?
Just I'm making a more generic, general graph. In this case, since you released it from rest, it could have started at 0, 0. That would have been fine. I'm making a more generic graph because it won't always start at 0, 0. So that was intentional. But if you're, in this particular lab, if you release the car from the top of the ramp, it would start at 0 and go down.
Right.
As long as it doesn't start positive. Yeah.
So acceleration never implies like direction you're going into.
If you just had this purple graph, you could go and you were going to try to go backwards now. From here, you would have to guess which of the two. Ultimately, going to be 2 positive and 2 negative accelerations. If you just had this graph and no other information, you wouldn't know what was happening. You would know it's one of 2 scenarios, but that's all you could possibly guess. Much like if you just have the velocity graph, you have no idea where the thing starts. Like physically, is it positive or negative position? You can guess, again, one of 2 scenarios probably, but that's all you can do. It's excellent. That's an excellent question. Any other question about the third one? All right, last one. Here we go.
Actually, second to last.
Huh? Well, the fifth one is not a separate one. It's a extension of another one. The fifth one is really if I just took this second one and let the car roll back down the ramp, I would just draw the line further. But we can cover that later. But there's only 4 really distinct ones. All right, last one then. We have a cart, push it up towards the sensor. Who wants to give me an idea about their graph here? So it should look like that, the fourth one. A skateboard ramp, if you will. So can someone explain that to me in layman's terms? Brent. The name just came to me. Remember it.
It's decreasing.
What's decreasing about it? Oh, you're good. Sorry, decreasing velocity. It's up too soon there. Decreasing velocity.
Going in the negative direction.
Negative direction. Anyone disagree? I'm going to agree. What do you think? Does that sound good? Good. So again, we see this. We draw tangent lines. The slope of that tangent line versus this tangent line is less steep, but they both still have a negative slope. So it's decreasing negative velocity. So with this graph, everyone have this graph for me? Velocity graph. What quadrant do I need to be in? Top or bottom? Negative velocity, where should it be? Top or bottom there? Bottom. If it's decreasing, should it be moving away or towards it from the x-axis? Those are geniuses already. Nice. So I have a negative value that I'm below the x-axis, and it's a decreasing. It's really a decreasing value too, a decreasing velocity, because between -4, -3, -2, -1, that's getting smaller in the rate. You're cutting less meters every second, a decreasing velocity. And then my acceleration graph should then hopefully just be a nice positive one. Questions? All right, those are our 4 models. Let's recap a nice little matrix. Okay, we're going to assume for a minute here, as we're discussing acceleration, that we have an acceleration. Okay? So we're going to try and summarize how many ways we can accelerate. How many ways are there that my velocity can change?
2.
What are the 2? So I can either speed up or I can slow down. Those are 4 also very perceptive. There are 4 boxes there. Very good. How many ways can I move, assuming I'm moving? 2. I have a positive velocity or a negative velocity. There's my 4 boxes. Time scale here. So if I had a positive velocity, and in each of these boxes, we're going to attempt to draw or sketch very quickly a v versus t graph. Okay, so if I'm speeding up with a positive velocity, how would this v versus t graph look? The slope would, so would it be in the positive or negative area?
Positive.
It would go away or toward the origin.
Away.
So something like that. And we'd call that a positive or negative acceleration. Which one?
Positive.
Positive acceleration. Positive slope, positive acceleration. That's number 1. Okay? Now I'm going in the positive direction, but I'm slowing down. How would that look? Above or below the axis? Going towards away from the x-axis. Positive velocity slowing down. Positive or negative acceleration? Negative acceleration. Negative slope. Okay. Moving in the negative direction and speeding up. What do we got for that?
4th quadrant.
Nice. Like that would be positive or negative acceleration. What? Why positive acceleration? What's the slope of that line? Positive or negative? Negative acceleration. That's all it is. AM. That's all you gotta do for acceleration. Look at the slope of the velocity graph. That's it. The way I think about it, when I think about it, I think about it like a giant number line. I think about it in one, this is for velocity. One side has infinity on it, positive infinity. One side has negative infinity. Which way is my velocity going? which way my velocity going. In that case, my velocity was going towards negative infinity, so it's a negative acceleration. If my velocity were going towards positive,
Oh, goodness.
my velocity going towards positive infinity, I would know I have a positive velocity or positive acceleration, okay? So it doesn't matter where the velocity is, but which way is it going? Towards negative infinity or towards positive infinity? That's how you tell your acceleration. Just the slope of that line. Okay? And last one, going negative direction and slowing down. Yeah, that's positive or negative acceleration. Oh my gosh. Messed up my entire class. Jared. Come on. It was distracting for a while for those up front. Now it's too much. You can't control the chain. Okay, so those are my 4 cases of acceleration. That's all. It's all the 4 cases. 2 positive, 2 negative. The hard ones for most of you are going to be these bottom 2. Okay? If I was in my car, can someone describe what is 11:26, right? We're done? Correct? 26? Good. I always forget. Monday. Can someone, if you're in your car, can you describe how you would make this motion? Yeah.
Light turns green, you start accelerating.
Good. All right. I should have clarified my question more. What would you be in, drive or reverse?
Drive.
Messy Christina. Drive or reverse?
Drive.
Would you push the gas or the brake?
Yes.
Good. Gas pedal and drive. So if we're going to use bad words now, forward and speeding up. Okay? Towards your headlights, going that way. This one, how did I pull this off? In my car. John.
Moving forward with the
So drive or reverse.
alright.
I said drive or reverse. You said yeah, right. Which one?
Yeah, you can drive to the end of your
I said drive or reverse. I said.
Oh, I think you said drive in reverse.
Oh.
So you're going in reverse, but you're slowing down.
No, incorrect. Why would you say going in reverse? Are you have positive or negative velocity here?
Positive. Okay, so I was right, never mind.
So say in drive on the brake, right?
Stay in drive.
Good. Sorry, I mean to confuse you. Good. So you're going drive, put the brake on, assuming you're already moving in the first place. If you weren't moving in the first place, that won't work, obviously. Bottom one. First one here. How would I do this in my car?
You're in reverse and you're putting up the gas.
Good. Reverse going faster. So if you're back on your driveway, put reverse, and the gas on, bam. That's this. Yes, ma'am.
How fast can you drive a car in reverse?
1,000 miles an hour. I have no idea.
Depends on your car.
I'm gonna guess there's only one. Now I'm being not goofy. I'm gonna guess there's only one reverse gear. So I'm gonna guess once you start going over 20 or 30, it'd be very bad for your engine. Because if you stay in first gear in your car, most cars like 4 or 5 gears usually, then you're after like 20, 30 miles an hour, your car gets very unhappy with you. Your RPM spike up to like 9 or 10,000, and that's not good. So I'm gonna guess your car would not be happy with that. Now my car, the Prius, has a belt drive. So it doesn't. It has like a cylindrical gear system. So I don't know if it would matter really. It doesn't have gears like a normal car. So I probably go fast in reverse.
So for drag racing in the reverse, just get a Prius.
Yeah, let's have a land.
How much more power does the Prius have?
Don't know.
2.
Now it does. My favorite feature of the Prius, not my favorite. One of my favorite features. It does have a power button. When you push the power button, the car goes a lot faster.
No way.
Or it has more acceleration, I should say. Yeah. Because normally I drive it like eco mode, so the acceleration you can tell is like hampered to keep the gas mileage up. When you push power mode, tires squeal,
Probably could really
people die.
Well, it is electric, so it should accelerate faster.
But it's a gas filter hybrid. Both.
Well, I mean, it's got
Does fire come out the
It's
back?
got both, yeah.
accelerate faster.
No fire in the back, no, sorry. Alright, last one. Last one. How am I gonna pull that off?
In reverse, slowing down.
In reverse, push the brake, assuming you're already one in reverse. Okay?
At a high time.
That's all 4 kinds. Alright? Questions about those 4 kinds of acceleration? Anyone not like one of them? Try not to let you overthink it too much. Okay? You're not finding acceleration, look at the slope of the velocity graph. The positive slope, positive acceleration. Negative slope, negative acceleration. Don't overthink it. Okay? So you're gonna really try to. Really work on differentiating your brain slope from where the line is. Anyone notice, maybe some of you, it's a hard question to answer. Anyone notice what word I did not use at all today that maybe some of you thought I would use today? No.
Banana.
Homework.
The D word.
Deceleration.
Deceleration. Deceleration is equal as the word backwards and forward, which we use today a little bit. But we should know. Decelerate. Why I think decelerate is a bad word?
Because it's accelerating in a negative direction.
What does decelerate mean?
Slowing down.
Slowing down. Could it be anything else? Negative acceleration. There's two kinds of negative acceleration. So we don't really ever want to use the word decelerate because it has a lot of mixed meanings. If you say slowing down, it means slowing down going forward or slowing down going backwards, or positive negative direction, right? So decelerate is a very ambiguous again. So we don't want to use that. Okay? So always say positive acceleration or negative acceleration. Don't use the word decelerate.
We talk about this worksheet, it seems like a lot.
You can handle it.
Can you explain what a scrubber is?
Oh,
I believe at the time, I don't want to put you in a box, but I think at the time I was watching the show Scrubs.
Oh.
But it could be a toilet scrubber, it could be the janitor, it could be like those little bubble things you put in the toilet, they fly around the tub and everything, or it could be someone from the show Scrubs, or it could be anything. Again, they're meant to be intentionally ambiguous.
But I don't know which one.
Cookie Monsters.
Cookie Monster. Some people always write a certain kid's name every time because they're like friends with them. It's kind of funny. I don't know.
I think I like Dr. Cox.
I want to say one of your brother's friends always wrote Michael Smith on every single one. I don't remember who it was, but I thought that was the case.
You're making a velocity and it's.
I have 6 minutes so you can work on this. You might want to use pencil on this one. Those people love pen. Because you're probably going to make some mistakes. Puddle?
Give them the power. Hey, Jared. What? Jared. Yeah. Not you, Jared. We saw your.
For the
No, we never saw it.
I own it. I can.
I come back powers gets off with the.
Yeah, he was doing it backwards.
Oh.
So deceleration.
The first two notes aren't accelerating if you're on the X versus T side first. Right? So don't forget what you already know. Well, do what you were doing last chapter. Or draw line at 0. Don't write an A. We'll find out.